Alrighty, I am back. I got a forcibly fire alarmed out to lunch at the end of the last stream. I don't know who, if anyone caught the exact moment. It was real quick, but we're back. I don't remember what we were talking about, but I see we got Paging Turner still here, so you remind me we can pick up where we left off. I'm just about to get this alignment thing working. Section flags. Right. So what we have to do is take flags, bit shift 20, OXF. This is going to be a shifted code. Okay, our result is going to be this. If the shifted code greater than 0, then 1 bit shifted code minus 1. Give us our result. So this is, you see, we got 1, 2, 3, 4 here, turning into 1, 2, 4, 8 here. 1 bit shifted by 1 gives you 2. 1 bit shifted by 2 gives you 4, right? So it's all off by 1. So that's why there's a subtract 1. And now we can calculate the alignment correctly. Okay. So we align the cursor for the object. Save that position. Increment the cursor. So this is laying out a section location for each section here. And then we need a symbol table at the end. I think we probably want to align that. All right, so what do we got? Section table, section data, FO file one pass last. Symbol table, file offset. We still need the size of the symbol table. That's gonna be the record count. But there's a little bit more that I'm missing. There's like a string table in there too, right? Like PE table. Surely we're also grabbing a string table. Right, so there's 4 bytes here for the string table size. Do I have all of this up here? Symbol. Doesn't say anything about the symbol table. Garbage. Yeah, so this is string table size, a U32. Is this right? How can this be right? The table size doesn't include the extra 4 bytes for the... Oh, the extra 4 bytes happens after the symbol table. And so the size of the string table includes those 4 bytes. Gotcha. So we have... symbols, right? And then we have string data. Got it. Symbol record count times the size of PE cough symbol. String table f off goes there. And then how are we going to know the string size? We don't actually know how we're going to know that yet. So we actually need to figure out the string table size. What is the string table? Where do all the strings come from for the string table? They're for the symbol names, right? So we need a string in the string table every time there's a string that doesn't fit in 8 bytes. Okay. Okay, we want to look over each symbol. If we get the symbol fields, we should be able to say if the name size is greater than 8, then string table size plus equals the size of this, right? So 8s and less can fit inside the raw version. But over 8, we have to stick it in the string table. String table f off plus string table size plus 4. The string table size we have here is the string table size not including the extra 4 bytes, right? There we go. There's all of the layout calculations. We also know about the string table size problem. Now we can start flattening out more of this file. We've got cough header is part 1. I think we can just do, yeah, we can just do allocate that buffer. Okay, so fill sections. And I want to iterate the sections, which I've got an example of up here. Fills set section. Okay, so for each section, go grab those section fields. Okay. And we're going to want to grab the section header struct real quick. Plop it right there so we can see what we're doing. And then we're going to want to do okay. Okay, we're comparing that with the inner fields of the section type. Copying from there to there. So that and that are done. V sizes just come out as 0 in object files. Same thing with V offs. These are all just 0. They don't get assigned until we're making an image file. F size. For now, we're gonna ignore BSS, but support true BSS. Now we'll just say that fields data size gives us what we need. Now the F off is going to come from, we have section off, that's up here. Section F offs I. One section F off for each I in the section count range. Okay. We skipped relocations up till now, but that's real too. Relocations F off, relocks F offs I. We'll have to put that down. Line numbers F off will just be 0. Line number count will be 0. Line relocation count that'll come from the intersection fields relocation set count. Flags to flags is all that's left. Okay. Symbol record. Symbol table F off. Symbol table F off is actually known now, so we can fill that in. But now we don't have the relocation F off. So everything that was broken is fixed, but new broken stuff exists again. That's progress. Times the size of a relocation. How big is our relocation? Cough. Relocation is one of these. So it looks like it's probably going to want a 4-byte alignment. And we can put that in right here. Alignment might also be different. I might not want to align the cursor at a BSS section, so I'm going to put that all the way at the top right there. And then align cursor for relocation. Nice. Okay. I'm going to take a quick 5-minute break here. And when I get back, we'll see how far that is. I think there's still more to copy into the serialization buffer there. Well, let's see. Let's see if we can do a... Hold on. Let me get this set up properly. I'm going to put this here. That'll make 4Cutter a lot faster. And I don't know if people on stream can hear it, but there's another fire alarm. Not my building, but it's I hear it from outside, and I can hear sirens. I wonder if it was a real fire this time. Anyway. Save off. We have relocation offsets now. Great. Then we want to render out the symbols. Well, no, first we gotta render out the section data. What's going on here? Section headers to go there. I want to look at this down here after section headers. There's the data for each section. For each section, get the section fields. We're gonna do this like this so that we can do that again in another scope. Okay, so we copy into that from that. Section data. Then we need to fill the relocations. So section fields relock set count. Forgot about that. We need to just do this logic here, wherever we're accessing it. Okay, so the thing we have to do here is get the output array location. So that gives us the relocations array. That gives us the one we want to fill. The last thing we have to do is we have to get the relocation fields. So we read each relocation fields in order to go relock off equals relock symbol index equals relock type equals, and then relock fields have an offset. We're gonna have to figure out how to get the symbol index, and they have a type. Okay. symbol index from let's see how this works. So this is an ID. So what we want to do is resolve that ID according to the normal resolution rules. Symbol goes in and a node maybe comes out. If a node does come out, then the symbol index is going to be node reindex is going to be an array on our scratch. Okay, so now I can use the reindex right here We get the symbol's actual index in the output array. Okay, so where is that? I've got relocations filling. I've got section data filling. Got section header filling. So I think all that's left is the symbol table and the string table. I could read this out of the reindex again to find out where I'm supposed to write this. Buffer plus symbol table f off. Why don't we make that the symbol table itself? Okay. Okay. The symbol records. Alright, I guess we need to grab the symbol record. Extract like that. compare it to the tank symbol fields. There we go. Okay. If our field's name dot size is less than or equal to 8, then we're going to memory copy into the record raw otherwise we're going to set the records name.0 field to 0 and the records name.string table off to string table cursor off. This is going to increment by name okay, this is the field's name. Name.size plus 1. Name.size is wrong up here. I would need to add a null terminator at that point, right? Table off. Name.size plus 1. Memory copy string table buffer plus string table cursor off, copy the name.string name.size. Add in the null terminator and increment it one more time. Okay. That should be the right way to fill the name. We gotta set up this string table stuff still. The string table cursor will start at 4 so that the offsets we are writing into the symbol records actually are offsets that include the 4 bytes of size at the beginning. That's intentional. And we're indexing off the string table that way. So all we have to do is take our string table size and write it in right here. This is the first 4 bytes of the string table. 4, 8. Okay, this is 8, 12, 14, 18. Is that right? Is symbol type? Large class is 1. Symbol type is 2 bytes. 2, 4, 6, 10, 18. Right, it's a multiple of 2. Weird. What if... do we know if there's an alignment of the string table? I don't think it's aligned, so I'm gonna say no, it's not aligned. The string table is just that plus that. Okay. Okay. Okay, I think we're good on that front. The record value comes from the field's offset. The record section number comes from 1 plus the node reindex. Yeah, we gotta calculate the section number separately. index doesn't work out very nicely in this case. We want that index there. We just are going to need like symbol node on this one. We're going to do it again. But this one is going to go through an access because we're reading it off of an input ID. The fields contain a section which we want to turn into an access to a data node. If that succeeds, then section node can be normalized into a index and then re-indexed to get us a section number. Well, we don't even need to do that. All we have to do is go node reindex index equals 1 plus I. Then we can drop the one right here. See, like because the reindex here bakes in the offset by 1. Get the section number from the reindex that way. Okay. That's how we decompose the kind. That gets used to tell us about things like the symbol type. get the section node pointer as the section fields. Now, you want to look at how the section header itself was getting filled. Relocation count. What else comes in the aux header, or in the aux record? Line number count. Checksum, I have to go figure out how we calculate the checksum. Don't know. Section number is our sec number. We already calculated that earlier for the in the outer group. That's good. All right, so comdat selection, we're punting on that. But checksum, we're not going to punt on. We're going to go see if we can make sense of that right now. Checksum. Okay, so it's combat sections only. That should more or less do it. So, from what I'm seeing, it's actually pretty easy to just flat out render one of these files. The thing I have to do here that I was probably trying to avoid is I have to do a manual calculate layout, and I have to include the entirety of the layout of the file in this section, and then that means all the rest of this is kind of just a giant flat ongoing thing that renders out the file, right? So what the block abstraction let me do was it let me arrange all these without ever having to do the actual calculate layout part, right? The layout was sort of automated. The way I did it here, I just calculated the layout manually by knowing the rules of how things would get laid out, but there's subtle coupling everywhere. Like the fact that this comes here like that with the 4 has to match the fact that when we fill it, we put the 4s here and here. The things like the names of the symbols. Where did we put that one? The string table size. Yeah, like calculating the string table size has to be correct. So you have to, again, you have the null terminators counted for once and then twice. Right here. So I think that's what I was worried about before. However, it is looking like it is significantly simpler in terms of total lines of code for just this one format to work this way. It might be the case that there's a critical mass, right? It might, for instance, with the PE executable file, you take all of this and you add in another DOS header and you add in a PE header and you add in an optional header and you add in data directories and then you add in, you remove the symbol table part, but you have some other stuff like base relocations that replace the relocations that you have in an object file. So I could totally see why I might feel as though, and then also the layout problem is harder. It's more specialized because there's a virtual layout and a file layout for every section in the image version. So I could see how like maybe that gets to the point where it's too much to ask that um that you do it all by hand flat, but I don't know because I was also trying before to do it in such a way that they were interconnected and I never really felt good to work with it anyways. So maybe the answer is just skip the block thing and do it by hand until it gets too big, and then when it does get too big, then maybe the block thing is still the right way to go at that point. I don't know. I don't know. Figuring out the right way to program it is the difficulty with programming the block thing is that it really hides a lot of the information about how you actually assemble the file. It's not obvious from the code because of the fact that you can abstract. You can then say like, okay, render out all these blocks, you know, like the section table and then the section data blocks and the relocation blocks, and then as you're doing this, you're putting patches in, but you never really see until the last moment, like, oh, we put header here, section headers here, section data comes out in this loop here, and then the symbol table blocks come out here, and it all kind of gets laid out in that one spot. But how do I want to put this? It's flipping the work. The calculations you do to put the header in place and to do the final layout of the file happen at the very end instead of here at the beginning. And something about that feels harder to pick apart into a description, right? It's more like you start reading and the first thing you see is like section headers and section data. Like you see these things first, and then you see the pieces that build up until you get the whole. Whereas here, I'm a little bit more like, hey, we're gonna just do a kind of iteration across. This is okay. Here's another thing where it's tricky. It's sometimes a lot more work than this to do all of the. There's a lot of pre-calculation that becomes necessary. Here, I had to build this re-index data structure in 2 passes. I also had to build I had to get a special count of the symbol record count. I had to get a special count of the string table size, and then I had all of the condition information for actually calculating the layout. That could get a lot worse, right? If there's a lot more optional stuff. So yeah, that's the issue. But with this one in particular, I think that it's workable so far to do it flat. Um, okay. I do start to wonder, the idea is popping in my head, like, what if I used symbol sets to program a parser like this? Because I could start to see something like, what if each symbol stands for one of these paragraphs of code? And so this little paragraph will get rewritten to be inside of the function body for a symbol. And then the symbol itself has some kind of type, so maybe it represents the information it computes as its output type, and it has some kind of ability to declare, like there are links so that, for instance, well, there's hard stuff like, okay, the node reindex is calculated by completing these 2 paragraphs. How do you, what is that? Who is that in the symbol, set? What are the semantics of the symbol set where some things are calculated by some nodes calculate one thing, but some values require 2 processes to compute them, or two calculation paragraphs to compute them. But that those could be separated and done in either order. I don't know. It's a little bit much, right? It's a little bit too much. But something there that's kind of interesting. Like if eventually you could describe the pattern of the file as the interconnected rules of each conversion in a systematic way there, then I think at least what I'm imagining could happen is that it could sort of do work in this order. So you wouldn't use a block abstraction that fundamentally defers the layout to the end. You would still calculate the layout up front. It's just that the system would figure out the tendency graph for you, or I don't know. I don't know. Stuff like that doesn't usually work out as nice as you'd hope when you go for it. A little unsure what might be the best way to organize this kind of code, but we should test it. So we're building Tinkercoff. We run. Doesn't crash. This just means we need to go look at the diff. So give me a moment to get set up to look. Do it. I'm gonna pull up on my other screen. I've got File Pilot going. I'm going into, well, I'll show you. So we got test out, right? These two. I can drop each one of these in. The one on the left should be the original dump. The one on the right is the dump of my why isn't it in though? I don't see it coming in. Not drop right there for some reason. Select it. It'll work. What's the deal with that? Wait, is this file empty? Why is it empty? That's weird. Hold on. When this runs, okay, what am I messing up? It must be result data or something, right? Result data equals buffer file size, something like that. Yeah, cool. So now let's try it. It's actually got reasonable size. Find the difference. Hmm. Hmm. Okay, so the relocations are super wrong, first of all. Startable method. Yeah, so all the stuff regarding the section is right, but the relocations are way off. Let's take a look. That looks like maybe the relocation is just being, like, the iteration over the relocations is just not implemented correctly somewhere. Relocks tells us to output. Okay, so we're outputting to the right location. Are we... we're just using I every time. That's not going to work. You need to use J to index the relock indexes for this to work. This is where I wish I had typed indexers, right? This is supposed to be ranging over the set of indexes into this relocation set. And so it shouldn't have the same type as the indexer ranging over the set of sections. But the difference in type is something that would have to include references to local variables in the types themselves. Right. Clear. Find difference. Okay, that didn't fix anything. Did I fail to run it? Yes, I did actually. Mapped. Base. Find difference. Okay. So it's wrong by symbol index right off the bat still. But the other details are right. That's cool. I'm assuming that's just going to be true all the way through. Now the symbols themselves, they're not identical, but they're very close. Okay, so for some reason the section number is actually 0 in these. Okay. Um why though are those symbol indexes wrong in all of the real? That's interesting now. Symbol record count. Um um that seems right. So the question is there an issue somewhere else with node reindex how we're using it? I mean, this must be wrong. Let's take a look at which symbols these are. So this is saying 78, right? This is saying 67. Just go take a peek. Symbol number 67 is this one. How many auxiliary records have there been before? 1, 2, 3, 4. 20, 29, right, 30. Okay. Uh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, I can see how 67 could become 78 if it's adding in the auxiliary records more times than it should be. I'm a little confused why that doesn't work. It's putting all the right stuff in all the right places. But that's ending up in the right spot. Maybe we're linking them up in the wrong way when we parse it. So each relocation that's its symbol. By indexing into symbols, the problem is this needs to be getting an extra increment whenever this happens. Right? I mean, there are two different interpretations here. I don't think we're actually using the second one. When we fill these in, we're only using them for this reindexing purpose, nothing else. So they should actually just use a symbol index based on the actual index of the record. When we go to ask what's the symbol tinker ID for this, what's the tinker ID for the symbol that you get at this symbol index, this array answer. So this is the name I actually need. This is okay. Still not an exact match, but let's see. Looks like it could be very, very close. Let me pull it up in here. Okay, so the BSS section is not supported correctly. We knew that would be in there. So what this is saying is we need to actually give proper BSS support so that the BSS section won't put any real data into the buffer or into the file, right? All right, so here, okay, right. So special symbols don't want to put a 0 down. They want to put a max U16 down. Okay. We've got that BSS section issue. All right, what is this? Our data appears to be missing some of its data. This might be ComDat related stuff here now, right? Um, let's see if we can figure out what these are. So this is 2, 4, 0, 2, 4, 6, 8. It's 4 bytes starting at offset 8. Zero, 4, 6. Wait, that doesn't make sense. Double check here. 0, 2, 4, 6, 8. 0, 2, 4, 6, 8. Line number count. These can't actually be right. It could be that it's the checksum, but that would be at 10, not at 8. 14. Oh. 4, 6, 10, 14, 16. This is too big. I think this maybe is supposed to be a U16. Number of lines. Yeah. 2, not 4. So we can't just punt on the checksum if we want to make it match. We need to get it right. The that should make the first difference, but now we have to figure out how you calculate the checksum. Wait, was it every section? No, it wasn't every section. It was this section. Words. It was this section that came with the checksum, and this one, 2. Do they all? No. Yes, all of the symbols that have the checksum are failing, but some of them, some of the data sections symbols don't have a checksum. So there are 2 questions here. One question is, how am I supposed to know what the checksum is? Can I calculate it myself? And the second question is, how do I know if it goes there? Like, how do I know when there is a gonna like? Is there always a checksum, or is it? There's. It's not. So how do you know when to leave it out? We could possibly determine that by looking at the original file and then making that a field of the section, in some sense. What is this one? That must be the comdat selection. Done it? We have two R datas or something? R data section number 7 is different from R data section number 15, I guess. One has a checksum, one has comdat selection. Oh, I don't know. Both. Section number 7. Okay. What do we have in the section flags? Right? Got these sections. Section 1. First section 7. Initialize the data. Let's just start taking some notes here. And later, section number 7 gives us checksum. Okay. And the next occurrence of R data for 15. All of this is all working fine. The question is, right here, we start seeing them listed out again. Each of these, this is weird. This one has checksum of 0, but a data of 2, and then this one checksum. And, okay. Well, let's see what happens here. Section 15. Has these flags. The checksum. Let's see. It's going to be section number 15. We get no checksum. Comdat select equals 2. Then for 16, we're seeing the same flags with a checksum and combat select equals 2 again. Now I'm just writing this all down because I don't know what any of it means. I want to get a feel for all the things happening. So all of those are the special ones that have that comdat select field set to 2. They all have this link flag for comdat. Our other mismatches happen here. This is section number 11. That has these flags. Has a checksum, I can't remember. Comdat select equals 5. Section number 11. Comdat select of 5. Oh, there's also an A right there. What is that one? One base index in the section table for the associated section. This is used when the comdat selection setting is 5. Okay, so this is a second it's not supposed to be the section number of the section. Rather, it's an associated section. Which So here debug $S is associating with section number 5. No, section number 10. Debug S associated with text M. Got it. So here we have some executable code, and this is giving us debug symbols for that executable code, I assume. We have a .debug2 with no comdat. Debug 11. Section number 2 doesn't get one of these special comdat links. Presumably, though, this is just the debug data for section. Okay, so all of these are issues with understanding checksum and comdat features, except the BSS stuff. Right, this is the one other type of error we have, which is not related, or at least, it's not related. So I think that's pretty great progress. That means that at this point, everything is matching between these two except those last two little corner case things, those last two special features. Let me see where I'm at on today. It's only been a couple hours. I'm going to take a 5-minute break. When I get back, we're going to try to tackle the BSS section part. And I think that'll be it for today. All right. So I will set up a sign. I'll make it a 10-minute break. All right, I will be back shortly to do one more little push on this stuff today. See you before long. Okay. Okay, let's start with. I'm reading about the checks. Oh wait, no, we're not doing checksums today. Um, we're gonna do. Oh man, I am a little motivated, but I guess for now I'll put the 0 in. Let's do. Yeah, let's just do BSS section like I said, and wrap it up there. The question is, how will we know when we have a BSS section? There's got to be a flag or something. Uninitialized data. That's probably the hint. What does this look like in the PE table dump of it though? That's worth checking out. Okay, the sections. BSS still says 224 in the file size. It says 0 in its F off though. So that's another hint. Right. See what it says if I track down this name. So sections are lines of 4 by boundaries. Let me double check I did that. Calculate layout. I kind of think it's saying that it doesn't need to be this. It needs to be this. Okay, I think that's all it comes down to really. If it has that flag, we're gonna say that it's got the BSS property. if zero data so it is zero data if this flag is set. So if it is not zero data, then you align the cursor, save it in that slot, and increment it. If we don't save it, that'll be a 0, which will be correct. That'll mark that this is a zero data section. It might still have relocations. I think we just leave that part. Okay, I think that's about it. Here, we output the F size, we output the F off. Those will actually just be automatically correct now. Here, we want to say if this is not equal 0, then we can do it. That supports true BSS because those will be 0 in that case. And it'll always be invalid to write to 0, so this will just be our way of encoding or not writing out the block in any case we want to do that in. And I guess this will have a similar logic. It's never valid to write to 0. So that's the header. You only do all the relocation stuff if the relocation F off is even valid. We get it? All right, so our first error is all the way down here. I think that means the BSS section isn't an issue anymore. Zero, and yep, after going through my rewriter, it still says 0 there, so it's not attaching the data section anymore. Okay, but now all that's left is this comdat stuff. This is what I'm gonna have to figure out tomorrow. This might just be additional information that I somehow have to carry through my new data structure that I haven't accounted for because it's not a part of the main data structure, but it's super buried in this like side thing that we are finding it in. And so I might have to raise that up to the level of the symbol or to the level of the section, and then figure it out from there. Yeah, I think those are the last of the errors, are the ones that look like that. Which means that tomorrow, if we finish the Comdat section stuff, we'll have passed this first test. The testing my own object file, going through the rewriter and through the logger. Then I can check it out in the hex differ, make sure that it matches there, check it out and by passing it through the linker, make sure that it actually works. If those things are good, then I can start looking for more sample cases, right? More sample data, expand my test suite with, and also a fuzzer could be on the horizon next. Make sure that the rewrite library is fundamentally correct. Yeah, a lot of cool stuff coming up next, but I think this is a good place to stop for today. It is looking pretty promising at this point, so I'm optimistic. I'll still don't have a full week on my hands here, but I think I'll be back tomorrow, at least for a few hours in the morning. If not, I'll try to be back on Wednesday. After that, it's not maybe clear if I'm going to be available or not. But I think we could be looking at getting the first full test case completeness done as early as tomorrow here. So keep your eye out for whenever I come back next to work on that. And I'll see you all around the internet later. Bye.